Okay, so we're going to start with the review. We're going to start with question 9D.
Are you recording?
Yep. 9D, 2x plus y. 2x plus y equals 7. X minus y is negative 1. Minus y. That's 1x compare. Okay. So, we have our two linear equations. It always helps if we number them. 1 and 2. We're going to be using elimination to solve these. So, luckily, the coefficients in front of y are already the same. One is positive, one's negative, the only difference. But the unit value is both 1. So I don't need to multiply either of these equations by any numbers. Okay? I'm going to choose an operation. I'm going to rewrite it below just so we get used to our style. Because y is positive and the other y is negative, I'm going to add them together. Adding them together will eliminate both of the y's. So when I add them together, the y's are both going to disappear. 2x plus x is 3x. 7 plus negative 1 is 6. So we have 3x equals 6. X is 2. So I eliminated to find for x. I'll use elimination to solve for y now. On the other side, same two equations, 2x plus y equals 7. You could just substitute it. I'm going to do another style of elimination because that was really easy. We'll make one a little more challenging. X minus y equals negative 1. Okay. In order to eliminate my x's, I need to have a coefficient in front of the x that's the same number. So, the top equation has a 2 in front of the x. Bottom one has technically a 1. So all we have to do to find a common multiple is times the bottom equation by 2. We don't even have to make a change to the first equation. So we're going to multiply the second equation, every number by 2. Our two equations will then be 2x plus y equals 7. 2x minus 2y equals negative 2. Now that I've done that, I have two linear equations. The coefficients in front of the x are the exact same number. So because the coefficients are the same and they're both positive, we're going to subtract the 2 this time to get rid of the x's. When we subtract the 2, both x's are going to disappear. We're going to have 1 subtract negative 2. We're going to calculate that on the side just so you can see. That looks like this. 1 subtract negative 2, which is also 1 plus 2 is 3. So when I have positive y subtract negative 2y, I end up with 3y. 7 subtract negative 2. Good, I'm glad you guys are getting better with that. 9. Y equals 3. So, using elimination, that was pretty quick. My point of intersection is 2, 3. My x is 2. My y is 3.
What are the other ways to do this? Just substitute.
Alright, so that's question 9D. It's all up there.
Hello.
Okay, question 12D, page 49. They've given us these two linear equations. When they've given us these two equations, they're not quite in the form we're used to looking at. So, what that means is we're going to have to expand and then simplify first. It'll make it easier to work with. So, our very first equation, I'm going to expand. The equation is 2x minus 1, 3 times y minus 3 equals 0. When I expand this, 2x minus 2 minus 3y plus 9 equals 0. I collect my like terms The only like terms here are my constant numbers, negative 2 and positive 9.
Switch it over.
So I can have 2x minus 3y
Equals 0.
plus 7 equals 0. Now, you guys aren't normally used to looking at it this way. Last year, you would have done a question like this called standard form.
Yeah.
We could just move the 7 over. It'll be a little more like what you guys are used to working with. So, 2x minus 3y equals negative 7. Still the same thing, okay? No, we haven't solved anything yet. I've just set up a question, okay? Question 2. Question 2.
Oh, shit.
Same idea. We have to distribute and simplify. So, 3x
Plus 1. No. 3x minus 1.
collect like terms again. 6 and 7. 3x minus y plus 13 equals 20. 3x minus y. We bring 13 to the other side. Becomes negative. 20 subtract 13 is 7. So, our two new equations now, up here.
We're done.
So we have our two equations. We're going to use substitution to solve these. Minus y equals 7. The other one we discovered was 2x minus 3y minus 7. Was it?
No, it's 2x.
I'll go check.
No, for the first one you wrote. 3x minus y, you put 3y.
Thank you. I did make a mistake. There you go.
Oh,
That's an x.
come on.
Okay. Now that we've done this, it's a little more like what we're used to seeing. Substitution. That means I need to set an equation equal to one of the variables. We're going to take the first equation, and I'm going to set it equal to y. So that means I'm going to move 2x to the other side. This will become negative 3y equals negative 7 minus 2x. To isolate for y, I need to divide everything by negative 3. Y equals 4. No, sorry. 7 over 3 positive plus 2 over 3 x. So, I've now put this to an equivalent equation. Ours is in fractions. When we go to distribute it, I'm going to keep it in fractions. If you prefer working in decimals, that's fine. You can turn these numbers into decimals if you guys like. I'm going to keep it in fractions because I like working with them. I find them easy to do without calculators. Okay? So, I now have an algebraic expression for y. I'm going to plug that in for y in the other equation. So, the next equation says 3x subtract 7 over 3, 2 over 3x equals 7. Once I have that, I need to get rid of these brackets. There's a negative sign in front of the brackets, so I apply the negative to both numbers inside. 3x minus 7 over 3 minus 2 over 3 x equals 7. Okay? So we're working with fractions now. We gotta get good with our fraction rules. I'm gonna combine my like terms. I have 3x and I have negative 2 over 3x. So what that means is in order to combine these, I need a common denominator. I need to turn 3x into a fraction with a denominator that is equal to 3. So 3 as a fraction is 3 over 1. I multiply the top and the bottom by 3. 9 over 3 is what it becomes. So we're going to have 9 over 3x minus 7 over 3 minus 2 over 3x equals 7. When I go to subtract these two, 9 over 3 subtract 2 over 3. I'll put it up here on the side again. Seven over 3. So I now have 7 over 3x minus 7 over 3 equals 7. Okay? We have 7 over 3x minus 7 over 3 equals 7. Okay? There's a way I can get rid of all these 3's and make this whole numbers. Carlo? Okay. One way to get rid of these fractions is because this whole side is divided by 3. If I multiply the entire equation by 3, okay, it'll get rid of this 3, this 3. 7 times 3 will be 21. So our new equation will read 7x minus 7 equals 21. That's a little easier to work with.
So isn't it times 3 by everything? I mean, at the top. So wouldn't it be like 21?
Okay. Now that we have this, we'll move the 7 to the other side. It becomes 21 plus 7, which is 28. X is equal to 4. Now, after all that work, I've actually only solved
For X? Is that it?
for X.
It is 4.
I need to substitute back in.
Don't cry.
We'll use 3x minus y equals 7. So we'll use our second equation.
Okay.
3x, did I say minus 2y equals 7? I think that was our original equation. That's why, guys, it's very important you number your equations. You can look up again. It's 3x minus y, not minus 2y.
So the first equation is, you're doing the first equation, it's like,
Second, okay? I have a value for x, so I can plug 4 in for the x. So this then becomes 3 times 4
will be 12.
minus y equals 7. 12 minus y equals 7. Negative y equals 7. Subtract 12.
Negative 4.
5. Y equals positive 5. So, our point of intersection, x is 4, y is 5. That's an extended question. It's a tough one to do.
Wait, chill.
Oh,
easy.
There's a lot of work to it. Elimination would have been quicker, faster way to solve this, but like I said, you can use anything you want to solve these guys.